Part C of this problem asks you about competitive industry and what will be the price. Now, we will use this equation, MC equals price, but to answer this question, but I'm not going to include this question in the second exam because we didn't cover competitive output in this exam. We're going to cover that in the third exam. So for now, don't worry about part C. We will come back to this question after exam 2. So let's move to the next question, which asks you about the production for men and women. This question is not going to be very different from the previous one, but the differences actually are going to make it interesting and worthwhile for you to review. First, let's write down what we know from this question, which is that the price the wage that men get, I'm going to call that PM, is $5.60, and the wage women get is $4. We also know that the firm is currently using 64 men and 81 women. And the production function here, these are exponents here, is Q equals 12M to the 1/3 W to the 1/4. This is a typical production, Cobb-Douglas production function, which we've seen many times. There's many different ways to answer this problem, but I think the shortest way is by calculating what are the marginal productivity per dollar spent on each input, and then see how they compare. If the company should probably switch to the one that has the lowest marginal productivity per dollar. The marginal productivity of men, I would start with that, is going to be equal to, using the traditional formulas we have for a Cobb-Douglas production function, is going to be the exponent of M times the output over the quantity of men the firm uses at the moment. So that's going to be equal to 1/3, which is the exponent of men, times the output that the firm is currently using, which is 144 units, over the quantity of men the firm is using, which is 64. Doing this operation, we get a marginal productivity of men of 0.75. So that means that when the firm uses 64 men to produce 144 units of output, the productivity of men is 0.75. The marginal product of men is 0.75. The marginal product of women, we can find it in a similar fashion because we know that it will be the exponent of the W times the Q, the output, over, now this time, the quantity of women the firm is using. So this will be 1/4 over, again, the output is 144, and the firm is using 81 women. Doing this operation, we get a marginal product of women of 0.44. Again, this means that when the firm uses 81 women to produce 144 units of output, the marginal product of the last women was 0.44. Now we can calculate the marginal product of men per dollar, which would be the marginal productivity of men over the price of men, and that will be equal to 0.75 over 560, which is how much men earn, and that will give you 0.134, using 3 decimal points so you can see the difference when I calculate now the marginal productivity of women per dollar, which is equal to the marginal product of women over the price of women, which will be the 0.44 we just calculated over the $4 that we pay women. You'll get 0.11. So what we found here is that the marginal product of men per dollar, MPM over PM, is actually higher than MPW, that the marginal product of women over what you pay women. So as we talk in class, given the marginal productivities, buying men actually, or hiring more men, is a deal, because when you hire another man, you actually get more productivity per amount of money you spend on hiring them than when you hire women. So what the company should do is to switch some production and hire more men. if the company wants to minimize costs, it would do so by hiring more men and less women. Now, you could have actually found the same answer if you had instead calculated the actual minimal values, minimizing cost values of men and women. You would have seen that that would have been ended up using more men than 64 and less women than 81. But you actually didn't have to do that, and I think this is a better way to solve this problem. None of the if you had used the other method, that would not have been incorrect. But I think this is a shorter way and a more intuitive way of solving it. As a matter of fact, we are actually going to do a little bit of finding the minimizing value for 144 in the next part of this question.